Okay, this is just a little reminder, I suppose, about the bits of chemistry that are relevant to the A-level. We're only doing this because you don't need to know it. It's just stuff that we kind of assume that you already know. But some people get quite stressed about it. So this is what you need to know. I'm not a chemist. Never going to be a chemist. Don't really know what I'm talking about. Okay. So off we go then. So the things we need to know what an atom is. Now an atom's the kind of the smallest unit of an element. An element's just a bunch of atoms that hang around together, all of one sort. And an atom consists of a nucleus which contains a neutron which has no charge and a proton which does have a positive charge. And that number varies and leads to periodic table stuff. We've then got electrons that are negatively charged, whizzing around the outside in a kind of a cloud. And they go around the outside in shells. The first shell can contain 2, and shells after that, I'm sure that this isn't completely correct, can contain up to 8. And the ones outside of that can contain up to 8. I'm not going to do any more than 2 because the elements that we deal with in biology are oxygen, hydrogen, carbon and nitrogen, and neither of them go any further than 2 electron shells, so just doesn't matter. I'm sure if you do chemistry or physics they'll do other things with you. So we've got these negatively charged particles, these are negatively charged, whizzing round a nucleus that is positively charged, and the attraction between negative and positive kind of hangs the whole thing together. Now what I've drawn there is a sort of a perfectly full set of electron shells, but of course all of the elements have their own different atomic number with different numbers of protons in the middle and therefore different numbers of electrons going around the outside, and it's not always perfect. And in order to achieve that sort of perfect 8 electrons in the outer shell or 2 electrons in the inner shell, they have to do bonding to share or to actually swap and give an electron away or take an electron from somewhere else. So we've got 2 sorts of bonding that we're going to come across. We've got covalent bonds, and this is where the electrons are shared. So, for example, in water. Water is composed of oxygen atoms. Oxygen has the atomic number. Got 1, 2, 3, 4, 5, 6, 7, 8. But it's got the atomic number of 8, which means it's got 6 electrons in its outer shell. And really, ideally, what it would like, if you like, is 8. And so it can form 2 bonds with hydrogen, which has only 1 electron in its outer shell. And so they share that electron. So that hydrogen now thinks it's got 2 electrons in its inner shell because it's got an atomic number of 1, so it just has 1 electron. And oxygen thinks it's got 8, and it's all happy stuff. We've then also got ionic bonds, and these are where they lose, so it's a loss or gain of entire electrons. Now actually we don't do much about ionic bonding in biology, but for example we consider hydrogen. Hydrogen has 1 positive charge in its nucleus and it's got 1 electron whizzing around the outside. If it gives that electron away to another molecule, it's given away its negative charge, and what we get left with is a proton or hydrogen ion. So hydrogen with a positive charge. So an ion is something that either has a positive charge because it's lost an electron, or it's got a negative charge, sometimes two, because it's gained electrons. And when we're writing them down, we superscript the charge. So H plus, the plus is superscripted. 1 plus means it's lost 1 electron. It's got 1 positive charge per atom. You might also see things like calcium. So the metals tend to form nice ions. Calcium can lose up to 2 electrons, 2 plus, or you could write calcium plus plus, just to indicate that it's lost 2 electrons. So that's what an ion is. An ion is a charged particle, and we will come across this. So the common elements that we deal with in biology are hydrogen, which we've talked about. That has an atomic number of 1, which means that it has its nucleus and it's got 1 electron. We also deal with oxygen. Oxygen has an atomic number of 6. It has its nucleus, it's got its inner shell full, and then it's got 1, 2, 3, 4, 6 in the outer shell. Is that right then? So it hasn't got an atomic number of 6, it's got an atomic number of 8. 2 and 6 is 8, yeah, definitely. Carbon, told you I didn't know what I was talking about, has an atomic number of 6. And that means that it has its inner shell 2, 3, 4, 5, 6. Now you see, because it's got 4 in its outer shell, 4 electrons in its outer shell, it's not going to be overly keen on losing any of them, so it tends not to ionize, and it tends to be involved in covalent bonding. But it needs to form, to make that perfect outer shell, 1, 2, 3, 4 bonds. So when we're dealing with carbon, we say that it can form 4 bonds, and it's quite a good way of checking your answers if you're drawing out molecules. We've then got nitrogen. Nitrogen's got an atomic number of 7. That means it's got its inner shell full. 1, 2, 3, 4, 5, 6, and 7. So nitrogen needs 3 more electrons. Again, it tends not to sort of give electrons away, it likes to share them, and it can form 3 bonds. So hydrogen forms 1 bond. Oxygen, 2, so it's got 2 lone electrons. Carbon, 4, and nitrogen, 3. And that's pretty much what you need to know. The other thing is when you're drawing bonding, so if we drew the bonding in a molecule of water, we've got the oxygen, a single bond to each hydrogen. So each one is sharing 2 hydrogens. Sometimes oxygen will form a double bond. So if you imagine you've got a molecule with carbon in it, it could form 2 bonds with the oxygen, and the oxygen's happy, it's shared 2 electrons with the carbon. The carbon now only needs 2 more electrons to share, and it might share that with a hydrogen, and it might share it with either bond with itself and do another carbon, in which case you need 3 more bonds on there. It could share it with another hydrogen, it could share it with an oxygen. Oxygen quite likes to share with hydrogen, so you might get oxygen to hydrogen bonds, and that's quite a common group in biology. So double bonds, 2 shares, we draw them as 2 lines. Single bonds, 1 share, 1 line. that is pretty much it. That's the chemistry you need to know. So let's not worry about it. We're not chemists, we're biologists.